Good morning, everyone. We would like to welcome you to our thesis today, presentation today. First, I would like to introduce you to my group, Sarah Ayman, Dunya Fahmi, Juanda Sarat, Saif Hamd, and me, myself, Abdurrahman Azan. Also, I'd like to tell you about our advisors for this semester and who will help us through our project. Our main advisor is Dr. Izzuddin Yazid Said Ahmed, and we also have other advisors that will help us through our project, which is Dr. Ahmed Imam, Dr. Khalid Nassar, and that's it. And Dr. Taran Breka. Our topic for this semester will be structural design of multi-story building. Quickly, I would like to tell you about what we will discuss in the next 10 minutes. First, we'll go with the introduction, then we'll follow by the background, data and design criteria, scope of work, methodology, then time schedule, expected obstacles, and finally the expected outcomes. So, the question is why we chose design as a sequence. We as a group feel that we are not that good in design, and we are not as good as we're supposed to be in design. So we decided to go with a design thesis. We had two options, whether to go with a complicated project in which will involve in too much analysis and too much research, and that's something we do not want to do. The other option is to go with a project which is more simpler, but will get us more involved into design and live the design experience. Other reasons why we chose such project is the availability of complete architectural drawings, elevation sections, plans, and everything. And also, it's easy to get a soil report for the intended land we want to put the building on. Now, Saif will take you through the background.
Please allow me to start by providing some general information, just to give you a feel about our project. Our structure is a multi-story building that is to be located in the fifth settlement, New Cairo. The main function of the building is to act as a commercial center, which should be confined to the lower levels, and as a residential complex. The plot area of our building is approximately 640 meters squared, and the total built-up area is almost 7,000 meters squared. The building includes two basements, one of which would contain a water tank, a ground floor, a mezzanine floor, 7 residential floors, and a roof floor. The total height is approximately 37 meters. Okay, this is the front elevation. And for further details, please allow me to refer to the cross section. Okay, I will start from the very bottom level and gradually move up as we progress. So, this is basement 2, and as I mentioned before, this is the one that includes the water tank. Following that is the first basement, which should act mainly as a parking lot for the residents and employees. Then we have the ground floor level and the mezzanine, which would be home to the commercial center. Then we have the seven residential floors, and finally we have the roof. Now the roof is split into two levels. The upper level, which to our understanding would include the maintenance rooms and the room for which the elevator will hold the machinery for the elevator. And the lower level would be primarily the recreational area for the residents, and this would include a pool, as illustrated in the cross section. Now, the existence of a pool on the very top level would require us to take extra caution while designing the slab beneath. Finally, I'd like to note that the architect provided each residential floor to have a height of 3.8 meters, which would actually be good for us since it provides more freedom to choose our slab system. And now I'd like to leave the floor for John.
In terms of the design and criteria, data obtained, we're going to use soil report in terms of technical data, and we have complete architecture plans in terms of plans, elevations, and sections to have a full image of our project. For our design criteria, we're going to have two types of loads. We're going to have the gravity loads and the lateral loads. For the gravity loads, we're going to have dead loads, superimposed dead loads from the MEP elements, and the live loads. And for the lateral loads, we're going to have wind loads, earthquakes, and seismic loads. In our design, we're going to use the most conventional typical design, so we're going to implement it here in Egypt. We're going to have concrete having compressive strength of 30 megapascal and steel of yield strength of 260 megapascal, which is high strength steel. Other elements we're going to be designed is the water-tight RC sections for water tanks and swimming pool. Our design will follow two codes. For the loads and calculating loads and forces, we're gonna use the Egyptian code for loads and forces for structure and for the calculating for the materials in concrete and steel, we're gonna use the Egyptian code for practice for design and complete of structure, ECP. And now I'm gonna talk about the scope of work.
Regarding the scope of work, we'll get into more details when we come to talking the methodology. But basically, we're going to take it through, we'll start with the foundation design, and we'll do a structural analysis so we can study the different loads in the seismic analysis. We'll go through a structural design, which includes so many elements we'll discuss in the methodology. We're also going to include drawing details, so we want our design to be extremely detailed. And additional items, if time permits, is that we want to do a BOQ and the hydraulic design of the water tank that Saif discussed was under the building. Regarding the methodology, the first step is based on the soil report that we will be attaining, we'll do the foundation design. The structural system will be picked based on, depending on the foundation that we chose, and as Saif said, we have a lot of freedom regarding that topic. Regarding structure analysis, there are new programs that will be used, which include SAP and ETAB, which we want to study the gravity and the lateral loads. For the structural design, we'll be covering the main structural design, which is the walls, the beams, the columns. But in addition to that, we'll be doing the swimming pool, the design of the swimming pool and the design of the water tank under the building. Afterwards, we'll be doing producing the design details, which are the concrete dimensions and the steel reinforcement drawings. And if time permits, is that we want to do a BOQ using Gravit. The purpose of it is that we're trying to target all three aspects of the construction industry in terms of the structural design, the managerial, and the environmental, which are all covered in the project.
Okay, this is our time schedule. It's divided in weeks. We're aiming to finish our project in 14 weeks. And due to the time constraint, we have a lot of activities that are overlapping to be able to meet the time. The expected obstacles, as mentioned, is it's a building, so it has a lot of elements other than the structural elements. We also have water tanks that will have a swimming pool, so this might be one of the challenges that we're going to face. Also, we have to study the seismic analysis, so we have to use the new programs. This is also going to be one of our challenges. And our main challenge is the time constraint, because we want to develop full and complete structural drawings. As for the expected outcome of the project, we want to fully analyze the system, and we want to fully design with all the complete elements of the building, including everything, and the hydraulic design of the water tank. And if time permits, we also want to develop the BOQ using the raft pool.
I'm going to start with just a comment. Please, in your scope of work, you can't start with the design of the foundation. Foundation usually is the last thing you design. How can you design the foundation if the second step is the structural system? What are you going to support?
We're not targeting a full design of the foundation system. We're just, as an initial assumption.
Whatever, the foundation usually comes as last. Is it going to be isolated footing, combined footing, or raft foundation? It depends on the structural system. It depends on the result of the analysis. So usually, yes, in construction, foundation is first. But in design, foundation is last. So please correct this. Now, if time constraint is one of your obstacles, I would recommend, with the permission of your advisor, to leave the management part and concentrate on what you are doing in structural analysis and design. And if you say, I'm not going to design the foundation fully, I would recommend design the foundation fully and leave the management part. Because this project is design, and inshallah in the second project 491, this will be mainly devoted for the management part. So this is my recommendation to you. Now the floor is open for anyone. Dr. Sheikh?
First, I would encourage you. This is very nice work. I'm sure that you're going to do something very good. Now, I just have one question. That you said that you have 2 basements. Now, do you know what will happen to the neighbor when you start excavating the soil? This is also one item, like Dr. Izzat said, that maybe when we are designing the foundation, we have something that we need to support the sides of the excavation. So it might be also a good thing that you can think of. Also, if you have groundwater table, I mean, I hope that you don't have, so that you will include something additional to this.
We will consider doing the retaining structure for if there will arise a problem for the neighbors. And we, of course, if there is a groundwater table, we will take the necessary measurements, but we do not anticipate that there will be groundwater table because it is located in the 5th settlement here in New Cairo. But of course, if there is groundwater table, which we will study later this week, we will take the necessary measurements.
I just have a comment rather than a question, actually, to characterize it question or not. They are not going to design the foundation fully at the start of the project. You're right, the foundation will come last. However, their starting point was to conceptually calculate the loads so that they can coordinate with the technical engineering in order to get the modulus of circulating action and start their foundation design. So maybe that was not clear in the presentation, but that was the point regarding the foundation. Thank you.
I have one quick question about the swimming pool at the top. You mentioned that the swimming pool might be challenging or problematic for the slab underneath. Do you think this is the main and the only problem that the swimming pool imposed in this design, or there might be something else?
We would also require that it would be water insulated for the water, as well as that it would be capable of withholding all this extra weight. But other than that, we haven't thought of anything.
Okay, I know that might be a little bit advanced question, but I'm asking to draw your attention to it. The size of your columns, the size of foundations, and everything could be actually governed by the size of the swimming pool at the top, because it's going to affect your seismic load dramatically. It's attracted to the building, so you might want to consider that point in your design.
Yes, we're going to do it in the analysis when using tap and everything and APAC.
Thank you.
I noticed that the water tank will probably be below the foundation levels. Unless you lower the foundation, you go the entire building. So maybe this is something you need to look at the beginning of the project.
Last comment, I'm going to say it, I'm not asking to comment because it's nice that you mentioned at the start you would like to have maybe a smaller scale of project, but you'd like to have it complete and integrated. I like that very much, than you have a large, huge project and we don't finish it. Regarding to what Dr. Wael said, I just draw your attention to what will happen to this full swimming pool if you have earthquake. What will happen to the water in the swimming pool? The slashing of the water left and right, this is something, if you like to have really complete design analysis, you have to consider this, and that's by itself, it's a nice topic for research. And there is lots of application of that. So this is more than just the weight of the water or the effect of the weight on the column, what's happening to the water that you have it inside the swimming pool if for unlucky reason that we have the earthquake with a high intensity. So this, please consider that in your design. Any other question? Thank you.